We were hovering, and now we are approaching the moon's surface.
The updated Chandrayaan-3 data indicate that despite a few mistakes, something strange is occurring. India's bold ambition has yielded remarkable results, propelling the country into the elite echelon of spacefaring nations. Furthermore, one thing is for sure: India won't give up. Following Chandrayaan-3's conclusion, the Indian space chief revealed some exciting news. Chandrayaan-4 will create a new sensation in a matter of years, thanks to a sophisticated lander and rover outfitted with cutting-edge technology. Beyond being a successful lunar mission, Chandrayaan-3 was a turning point in lunar exploration. There were huge hazards right from the start. Still, the Indian Space Research Organization, ISRO, launched this century-defining mission without cutting any corners. India spent over 31 million euros on Chandrayaan-3 alone to build the propulsion module and the probes. Only the launch vehicle required an additional 46 million euros to be spent by ISRO. For all of this, maybe to fail financially? Yes, but the Indians were skilled in their craft. Even after the Chandrayaan-2 disaster, which resulted in the loss of every probe but the orbiter, India did not hesitate to invest millions more in a second effort. On July 14, 2023, Chandrayaan-3 was launched from the Satish Dhawan Space Center with the audacious mission of making history by being the first country to soft land on the moon's South Pole. Even NASA has not been to the South Pole, despite the fact that we desperately need to learn more about this crucial area. The largest water deposits on the Earth's satellite are suspected by researchers, and we need to know where the water is if we intend to colonize the moon. The August soft landing of the rover Propulsion and the stationary research probe Vikram from lunar orbit was arranged by the Chandrayaan-2 leftover orbiter. Awaiting the momentous landing with great anticipation were space enthusiasts worldwide, in addition to millions more Indians holding their breath. A celebration of technology with Vikram and Propulsion. Though India is still relatively new to space research, the technical complexity of Chandrayaan-3's 2 probes is astounding. It sounds almost too good to be true. Secrets of the moon should be investigated by Chandrayaan-3 for the benefit of the whole world society. In addition to bringing ISRO national honors, greater understanding of the moon's South Pole would foster deeper ties with scientists throughout the globe. Russia was preparing a very comparable scheme at the same time as India. Additionally, Lunar 25 was intended to land softly near the South Pole. However, the mission was a complete failure. Not too many days before Chandrayaan-3 touched down on the moon, the Russian probes crashed. The propulsion module, the lander, and the rover made up the primary probe's first 3 main parts. The main objective of the module was to transfer the lander from Earth orbit to lunar orbit. More than 2 tons needed to be launched into space using a GSLV-Mk-3 rocket. The mission was launched safely and flawlessly from an orbit approximately 150 kilometers above the surface of the Earth. The 3 set out on their mission to reach the moon, each with a primary engine and a retractable solar cell wing. Both the lander and the rover resembled the probes from the Chandrayaan-2 mission in most respects. Naturally, Vikram, the fixed measurement station, was outfitted with the newest instruments and got some minor upgrades in the shape of even better landing legs. With Propulsion safely tucked away in the cargo compartment, Vikram was forced to make an autonomous moon landing after disconnecting from the propulsion module. It was impossible to maintain control from Earth, since even a few-second radio delay could result in catastrophic mistakes during the landing approach. Rather, totally automatic control was assured by ground contact sensors, an altimeter, laser Doppler velocimeter, cameras to determine location, and acceleration sensors. The probes, weighing more than 1 ton, safely navigated from lunar orbit to the surface on their own, with the assistance of data provided by the cameras and sensors. Vikram's computers determined the altitude, the ideal location, and the landing spot in real time on site. Every alteration in the surroundings throughout the approach was captured by the sophisticated instruments, and the surface was surveyed as soon as it arrived. The South Pole is said to be highly challenging for probe landings. Jagged slopes, sharp-edged, stone-filled depressions, and pointy rocks abound. While ISRO had a rough position, Vikram completed the remaining navigation on the spot. A smooth landing was guaranteed by 4 completely automated reaction wheels and 4 actuable main thrusters, which decelerated promptly with precisely computed counter-thrust force applications. India experienced a nerve-wracking fall, remembering the Lunar 25 accident the entire time. Then, however, unrestrained jubilation broke out as millions of Indians shouted as Vikram and Pragyan touched down safely on the moon. The event was televised live throughout the nation. Imagine the thrill of witnessing the two walk on the moon for the first time. It must have been somewhat similar for India to the first time that Neil Armstrong and Buzz Aldrin set foot on the moon. Vikram opened the cargo hatch shortly as it landed, allowing the small Pragyan to roll down a ramp. The tiny car shows off ISRO's astoundingly sophisticated technological prowess once more. Fitted with a solar panel and a very adaptable multi-wheel drive, this miniature measuring station was intended to go on lunar research missions. Pragyan can study the regolith rock as it moves along, since it is equipped with an alpha particle X-ray spectrometer that is mounted on a fully functional arm. The rock is heated by lasers using a specific instrument to provide more information about its chemical composition. Pragyan quickly discovered previously unidentified sulfur deposits on the moon thanks to laser plasma spectroscopy, and more research revealed that the regolith at the South Pole is rich in magnesium, aluminum, silica, potassium, calcium, titanium, and iron. Of course, Vikram started its task right away as well. The stationary lander was built specifically to record moonquakes and assess temperatures. Measuring the temperature of the lunar soil directly was the second intriguing mission. If we wish to determine potential ice deposits in the lunar soil, these figures are crucial. The temperature and thermal conductivity of the regolith can be directly measured by the Chandran's surface thermophysical XP experiment by drilling into the lunar soil. Furthermore, Vikram discovered that there are no significant ice deposits in the South Pole because the Earth is just too warm. The scientists were perplexed and now need to find fresh justifications. Soon after landing, the lander's 1-meter-long boom also scanned the plasma density close to the moon's surface, discovering a very high density of plasma there. In niche circles, the outcome is likewise hailed as a minor revolution. Finally, on August 26, 2023, a short 3-second moonquake was detected by Vikram's seismometer. Thus, the task of the two was a total success. However, the moon's South Pole has a few more dangers. In addition to jagged rocks and impenetrable craters, there's bitter cold here as well. The moon experiences 14 days of illumination, followed by a 14-day lunar night. Vikram and Pragyan had to go into a dormant state because it gets too cold near the moon's South Pole during the dark phase for them to continue functioning. On September 2, 2023, Pragyan was the first to be decommissioned. The tiny rover had already covered an amazing 101.4 meters and given plenty of useful information by that point. Before it took a break, Vikram accomplished one more minor achievement. The landing system's suitability for moving the lander on site was also evaluated by ISRO experts from Earth, and the test was a resounding success. Vikram raised itself to a height of 40 centimeters, hovered in mid-air, then descended safely to a somewhat distant spot on the ground. Following the lunar night, Vikram also went to bed on September 5th, 2023. Naturally, both probes were meant to continue operating, but this was also the point at which the Indian space travelers' misfortune started all over again. The signals from Earth were not received by either Pragyan or Vikram, and even their own automatic awakening feature failed to revive them. It is likely that Vikram and Pragyan succumbed to the severe cold. It is unclear why the ISRO chose not to equip the two probes with radiogenic heating elements, despite the expense amounting to millions of euros. The Indians attempted to make contact again for weeks, but eventually it became clear that Chandrayaan-3 was over. But since the mission's goals were essentially met, India celebrated its success nevertheless, winning praise from all around the world. Final salutation from Chandrayaan-3. Naturally, India was devastated by the loss of the two rovers, notwithstanding their victories. If Pragyan and Vikram had gone on with their objective, it would have been simply too good. However, everything was not lost. The propulsion module was the only item that had survived the catastrophe. The mission of this Chandrayaan-3 spacecraft, which was not lost, was to move the lander and rover from Earth orbit to lunar orbit. There was enough fuel left over after the operation to return the module. Using its engines, the module autonomously journeyed through the cosmos to Earth's orbit. India utilized the propulsion module's return to Earth after many orbital maneuvers and an additional month of flying time to conduct several critical tests. The amount of load that a propulsion module can carry from Earth to the Moon, and perhaps return, should be demonstrated through tests. Modules similar to this one will essentially fly from Earth to the Moon on a scheduled service once we have communities there. In India, the module's return was greeted with one tearful and one laughing eye. That some of Chandrayaan-3 had survived was a fortunate thing. Chandrayaan-4 is on its way. Who would have guessed it? Directly following India's official announcement of the propulsion module's successful return, Nais M. Desai, director of the Space Applications Center, revealed India's comprehensive Chandrayaan-4 plans on November 17, 2023. The obvious goal is to bring back large quantities of lunar samples to Earth. The launch is slated for 2027, and as part of yet another amazing endeavor, India will send multiple modules to the Moon. The soil sample will be taken by the lunar lander, which is expected to function as a measuring station like to Vikram. The intended lunar lander will thereafter be launched into lunar orbit. The lander will incorporate the launch pad for this feat, and the transfer module will transport the samples from the lunar module to Earth while in space. After a successful mission, the entire transportation series might be planned as a sustainable project that brings many more soil samples back to Earth. Check out the channel now. There will be a ton of amazing videos soon.